Thank you. So the Scrum Primer talk, which was just announced, is something I used to give kind of whenever I come into an audience where I think there's some basic knowledge in Scrum would be helpful. So this is basically just that I throw it in, and if you have interest, please come. So my talk is about Agile and quality. For me, they go hand in hand. You cannot have really quality without being Agile. It's a brave statement, I guess, but I'll try to explain it in my talk. So a little bit to myself. I'm the founder of the company called Effective Agile, based in Switzerland. That's where I'm living right now, and I'm working there as a change agent, basically going into companies and transition them from whatever process they have into Agile. I do this with small, medium-sized enterprises, 50 people, sometimes small boutique software houses, and the company I'm in currently is 20,000 people. And before I moved to Switzerland, originally I'm from Germany, but the last 12 years I've been living in England and mainly in the US as well, and that's where I picked up Scrum and was learning the trade. So when I started with extreme programming in 2000, there wasn't too much out there as literature and everything. It was mainly Kent Beck's book. So I had the opportunity to make all the mistakes myself and learn out of those. Oops, I need to be careful here. And so now I think there's a multitude of knowledge out there now 11 years later, and I think this is great, and the conference we are here today shows that as well. Okay, enough talking. Now let's dive into Agile and quality, what it means. So this picture is, for me, a summarization about how we usually ship software. I really like this picture. Somebody probably ordered a swing on a tree. Well, he got it. So what's wrong with that? Would you put your child on that thing? I mean, it's just one of those support pillars cracks. Huh. Or maybe if you're a really tall person, you always will bang your head. But it is a swing on a tree, so there's no kind of like, often, like with the Agile Manifesto, when you have this point like customer collaboration over contract negotiation. I think there we would probably have a contract negotiation going on. So this raises the quality, what actually means, the question, what actually means quality for us, because this is probably not the quality I had envisioned as a customer when I went in and I purchased or ordered some kind of product. So let's look what quality actually, what we're hearing about quality. So Six Sigma is saying it's the number of defects per million opportunities. So this is clearly from a production environment. Like you produce 1 million light bulbs, how many light bulbs go off the assembly line faulty? And this makes already clear that software development is not an assembly line. It is a product development, and product development per definition is a complex undertaking, so we need to have some different approaches to that. Nevertheless, let's look at what ISO 9000 is telling us. It says the degree to which a set of inherent characteristics fulfills requirements. So here we have the fulfillment of requirement. And Philip Crosby was also mentioned in the talk before. He says it's the conformance to requirements. So we can clearly see that it's about requirements. Fulfillment or conformance to requirements. However, we have one big problem. And the problem is that on average 35% of the requirements during a software project do change. So how can we cope with that? When our process does not want to change, if our process is not able to change, is not able to cope with changing requirements, is not able to cope with variation in general. This gives us then an architecture which doesn't scale. This gives us a monolithic software design which can hardly be extended, which cannot be tested and maintained in the long run. And this is causing that we get a solution which will look like that. So what to do? What can we do about that? And I really believe we have to go back to the drawing board and rethink for ourselves, what does quality mean for us? And the good thing is we don't have to think too hard because somebody else has done it already for us. Noriako Kano, he broke it down into two different kinds of qualities which are of interest for us. The first one is the must-be quality. It's the fitness for use. It's the intrinsic quality. That means that the product performs as we would expect it, that the product is reliable. All those things we expect. If we get into our car, we expect that it starts every time. Not every other day, every day. Another way to describe intrinsic quality is like, if I go to a hotel, I always expect to be that the room has a bed and a shower, probably a TV as well. I don't think about that. I'm not asking that on the phone when I order a room. It's intrinsic quality. Then the next point is attractive quality. And he says attractive quality is what the customer would love but has not yet thought about. And often if I give a product to a client, he looks at it and says, wow, this is great, but it's not what I want. And so therefore, we don't really need the attractive quality. And let's go back to the hotel room metaphor. If I go in there, and it's a really nice, comfy bed, it's like, wow, next time I can choose a hotel, I probably go there again. If they offer me a docking station for my iPhone where I can listen to music and get it charged in the same time, this is great. But it's not necessarily required. But if I can choose between A and B, I would probably use the one where I had perceived quality, which I said, this made me happy. I like that. And this, at the end, can mean that we get a completely different solution than what we set out to do. So in this case, maybe I go to a guy and tell him, you know what, hey, can you put a swing up on the tree for my nephew? And he says, well, what have you planned about? A big swing, small swing? I'm not really sure. So you can say, maybe I just saw this tire in your garage. Let's put it on a string and on a tree, and let's see if it's liked at all. If not, we can just take it down. If yes, we make a real swing, like a prototype or something like that. Discover what is really needed. So this basically also means that we have to find a way. So for the intrinsic and extrinsic quality, what we need therefore is we need to have two ways. One is to get the right product out of the door, the product which really makes our client happy, regardless of what he or she has anticipated in the very beginning, and it has to be of high quality. It has to work reliable. So to get the right product, that's pretty simple. So in the beginning, we have this area here, where we say this is our original solution domain. This is the area where we think our answer to the problem is somewhere in that area. And right now, we think it is here. It's this very point, and this is our starting point. So this would be our original plan. And there's nothing wrong with planning. Planning is essential, but plans are useless, as Winston Churchill used to say. So then we make the first sprint in Scrum and realize, hey, let's look at it. Let's collect some feedback. Let's inspect and adapt about what we have done already. And we learn, we resharpen our focus, and our solution domain shrinks. And we get a better understanding, and we can apply this knowledge into the next sprint. And we adjust, and then we kind of repeat that every time. And at the end, we have a different product than which we spoke about in the very beginning. And the point that we have here, this difference here, that's additional value we can generate. Because we are able to accommodate the changing thoughts from our client. So this helps us to get there. And if we just quickly summarize this approach here, when is the best possible point for us to start a project? It's essentially after we have completed it. Because at this point, we have learned everything about it. We have done all the mistakes, we jumped into all the pitfalls. Everything which could go wrong did go wrong. But we cannot afford to do every project twice. So therefore, we work in iteration, and every iteration gives us a chance to reflect and look back and apply the learned for the next sprint and repeat that. So we get better over time, and we get a better solution. So this is another point which is important. going back to adjusting to what the customer wants, because 60% of the features are rarely or never used. And this is the old, I think this probably is used in every Agile talk, this slide. Standish report, Standish group report. That means only 7% of the features are always used. The next 13% are often used. And that's the Pareto principle. That's the 20% which make 80% of the customers happy. Then we have another 18% which are often used and 70% which are rarely used. 45% never. So why do we implement those 45%? Because we tell clients, you have one shot of giving me your requirements. After that, you sign it in your own blood, and that's it. Everything else is a change request, because we don't like change, so we have to pay for it. And therefore, they want everything they can think about. But if we give the clients a chance to change their mind as we go and can incorporate it into our process, we will get a better and a different product in the very end. And exactly those adjustments points after every sprint, this is when we identify which features are actually used, which features are important, and we be able to descope maybe a couple of features and really focus on those ones which are important. And this is what we do in Scrum. So this is our initial product backlog. This is our requirements. And the requirement which is topmost has the highest priority. That's the one which will get done first. And the one with the least priority is at the very bottom. There's not one requirement next to each other. They're all ranked. In classical requirements documents, I see 80% of must-have features, 10% of should-have, and 10% of could-have. From those 80% must-have, which one is more must than the other? I don't know. So I do it alphabetically or whatever pattern I use. So I start off with a couple of items from the product backlog, which the team tells me we can implement those. With those, they go into the sprint planning meeting, and they create a so-called sprint backlog, which was shown this morning. That's the plan for the next sprint. In this case, let's say 2 weeks. That's the plan for the team to say, if we do this, we will have a shippable product increment at the end of the sprint. And with shippable, this means it's tested. And then they sprint and they have the daily scrum where they assess themselves to see how are we doing? Are we on track? Are we behind? What do we need to do to still reach our goal? Self-organization. The team manages itself. It's a very powerful tool. And then here we have comes a Scrum Master which enables and makes sure that this whole process is implemented correctly. The increment is then being shown in the review at the very end. And it's not only the product owner and Scrum Master looking at the product. It could be sales, marketing, who other stakeholders are of interest. Everybody. And then the team goes into the retrospective, the Scrum team, and figures out what it needs to change. Changes could be in the process, and changes could also be to the product backlog. So this gives us the right product, the extrinsic quality from Kano. How can we now make sure that we have a product of high quality? First of all, let's look at how we not get the right quality and how we work right now. So we have a software specification, and we throw it over the wall to the developers, and we throw it over the other wall to the testers. There's a clear separation, developers, testers, which is wrong for various reasons. Because then the testers read the software specification and they create code and executables. In the same time, the testers read the software specifications and they develop the testing specifications and tests. And then at some point, they go against each other. Now we hope they match. The problem with specification themselves is that it's written documentation, and written word is always ambiguous. There's always room for misinterpretation. If you just go to a restaurant and you read a menu, there will be fish or meat and salad for lunch. Do you only get the salad if they eat the meat, or also if I have fish? Let's say the testers implement, well, both will get the salad, and they say, no, only the guy with the meat will get the salad. Then we have a conflict here. Who is wrong, who is right? Who's going to answer that question? First of all, there's probably not going to be an answer for a really long time because the tester gets an email, well, you created a bug. The developer looks at it, says, no, works as designed, sends it back. I call it corporate ping pong. You can play it for quite a while. If you're under stress or something, it just works as designed, gives you a couple of weeks. And finally, if they really put their heads together and say, okay, we have probably an understanding problem. Who can answer this question? Because you have some specification here which will probably be signed off by 10 people. Who's going to answer the question? And if you ask all 10 of them, you will get 10 different answers. So this approach is not really working. So how does it work? Let's look at this one here. We still start off with software specification, and as you can see, it's less. We don't over-specify everything. We just specify what we will be doing in the next sprint. It's the lean process model, minimize waste. So then, before we go into the implementation, the testers look at these specifications. Okay, how can we make sure that what's getting created is actually working right? So the testers and the developers work together on that. They define the acceptance criteria. In this case, if we see this and this and this, it's okay. In that case, if we see this and this, but we cannot see that, that would be an error. We have to write it down. We will have to make sure this is covered. So we have a bunch of tests and specifications about what is required from the software. Then these are given to the developers, and the developers' main focus is to make those test happy. So they're not driven by the specifications anymore. They are driven by the tests. You can see where this is going? So that we have a sequence. We have specifications. We have acceptance criteria, which are coming from the testing side, and these then drive the development. So this parallel approach is gone. And from this, we create code and executable images. And then we look at all of this at the end, and we go back and we learn from that. And maybe we adapt some specifications or some ways how we go about that. It's a completely different approach, but it's required if you want to have a tested product increment at the end of your sprint. So what does this mean in detail? Let's look at the agile testing quadrants from Brian Merrick. And for me, this is the best way to describe what testing is all about if you try to work in an agile environment. It's 4 quadrants. You have a business phase dimension. You have a technology-facing dimension. You have something where you try to critique the product in a positive way, not just to bash it and make it look bad. And the most important is supporting the team. Tests which actually help the developers to write great software. So in quadrant 1, we have technology-facing and supporting the team, and these are our unit tests. This is where test-driven development is living. So here, for example, let's say we make accounting software. Here we could have unit tests for different depreciations for different items. Let's say you buy a computer, it depreciates over 3 years, something else over 10 years. And maybe you have some other laws which apply for certain kind of companies where they get additional discounts and stuff like that. So here we can make sure that all of those calculations are being done correctly. And because these are unit tests, we can automate them to 100%. We press a button, and we see immediately what is working. On the project I'm working on right now, we have over 4,000 unit tests. And they run in 8 minutes. It means with every change we do, we press a button, and after 8 minutes, I get either 4,000 something, yes, I'm still working, yes, I'm still working, and sometimes like, why, I'm not working anymore. I have a couple of broken tests. And the great thing about that is, to fix a bug, it usually takes longer to find it and isolate it than to fix it itself. But if a unit test fails, it tells you exactly, hey, here, this is the location, here, it's not working. Fix me, please. Then let's look at the next quadrant, the quadrant 2. These are business-facing tests, but still supporting the team. This is where we have the acceptance test, often also called the story tests. This is what the customer expects to see from the software. These are more higher level concepts, like flows through a system, business processes, and things like that. Like, for example, creating a new account, adding a new item to our accounting software, things like that. And this is kind of a hybrid where we have developers working and collaborating with business. If we go back to this slide here, this is kind of this area here, quadrant 2. This is where we define all of those tests. And the developers and testers are working together. Again, these tests we can automate. I'm not saying 100%, but 99.99999 and so on. There is sometimes this odd case where it just doesn't work. So I'm not saying 100%, but you should not give up too easily. Try 100%. On the system we're on right now, we have about 200, close to 250 of those tests. They take a little bit longer to run because they also exercise the system. They go to the database, they go with the network, and we run them nightly. The unit tests we run with every check-in, every commit, we execute them. Continuous integration was mentioned before. Now let's look at the next quadrant, business-facing critiquing the product. This is where we do exploratory testing, usability testing, user acceptance testing. This is classical QA as we know it. And it's still manual. There's no way to take out the human aspect. A good tester is really worthwhile in this quadrant because they develop the sixth sense to say, well, I click this and that, and I'm sure if I now click that, it will blow up. And it will, because they know their product. And then we have the fourth quadrant, the performance and load testing, security testing, and all the other abilities we have, except from usability, because that's covered in quadrant 3. And for this, it's kind of a little bit more like tool-based. You can buy some tools. Maybe you want to put a Perl script together or something like that. But there is no real answer out there yet. So yeah, it's an area where you can be really creative. More and more tools are emerging to help you to do that. But this is not something which is that well covered right now from the industry. So in order to have an increment at the end of every sprint which is tested, we need to do everything in every sprint. Why? Because we cannot test performance into a product once it's done. And we heard this quote this morning from Philip Crosby, quality is free. And it means that we have to build it in. Quality is nothing we can test into the product. So every sprint we need to be able to cover all of those 4 quadrants to have a high quality shippable product increment. And this means exactly, this is why it's important to have this quadrant automated and this quadrant automated, because then the human resources can really look at quadrant 3, the manual testing, and help out a little bit here if there's some manual work required. Because every sprint, my product grows. I add a new increment on top of that. That means every sprint I have to do a full regression test. How can I do that without automation? If my regression testing suddenly takes 3 weeks and my sprints are 2 weeks long, I'm out of luck. So if you can really take quadrant 1 and quadrant 2 out of the equation by automating them, you can really focus on this and this to make sure they are covered. And this is how you can have a sustainable pace from sprint to sprint to sprint to deliver high quality product. Now let's look a little bit. So I've been using Scrum in 2005 on a FDA compliant product. It was a life science software project. And there they have this concept between validation and verification. So validation means that the product is doing the right thing, and verification that it's doing the right thing right. And if you look at those quadrants, it means the quadrant 2 is the validation side. It's doing the right thing. And down here we make sure it's doing it right actually. And we had really complicated calculations in the software we were developing there. So these quadrants were really essentials for us. Here, for quadrant 4, these are our non-functional requirements. The system has to be scalable. The system has to be reliable, and so on. They are covered there. So we have everything addressed on those 4 testing quadrants. And here we make sure that the software is appealing to the clients, that they like to use it, and it's easy to use for them. Now let's look at how this maps to an architecture. Let's say we have a 4-tier architecture with UI at the very top, business, domain, and persistence, something like that. So quadrant 1 is living in the domain tier. This is where we have individual classes, and we make sure that every of those classes is working correctly, that the input and output is according to what we expect it to be. Quadrant 2 addresses the business side. Certain steps are done in sequence, and the sequence has to be in the right order, and maybe you have different conditions, and it changes the sequence. This is what we addressed up here, and we make sure that this is working right as well. Quadrant 3, the usability is in the UI, and you see this dashed line here. This is important because I cannot test quadrant 2 in an automatic way if I build business logic into my graphical UI. So if I have a button and somebody clicks this button and it executes automatically, it just doesn't work this way. We need a clear separation between UI and the business logic. Then we can test it easily. So quadrant 4 is this weird thing, because these are our non-functional requirements: security, persistence, speed, performance, and so on and so on. They are, I call them omnipresent. They can be everywhere. We cannot just say they belong to this tier or that tier. We have to be aware about them every time we implement something. So every time we implement a user story or a requirement, or however we call it, or a use case, we have to ask ourselves, is this affected by one of our non-functional requirements? Does this thing pose a security issue if it doesn't really work? If yes, we need to make sure it's addressed in the quadrant 4 testing. So everything we do, we need to make sure they are covered there as well. So how do we get there? And there's this nice graphic from a friend of mine, David Starr. So essentially, you take one of the user stories from the product backlog, and then going back to the sequence, when the developers and testers and the business people sit together, they define the acceptance criteria. They say, well, this is what we need to see in order to be happy. If you show it to me and it fulfills this and this and this, and it does not do this and this and this, then I'm pleased. So that's where we define all the acceptance criteria. And then we write for every acceptance criteria, we write an acceptance test, which is in the quadrant 2, and it's automated. And we can automate it because we don't have business logic in the UI. And then at first, all of those acceptance tests, they are failing. And then I take one of those acceptance tests and I go over into the test-driven development mode. And I'm working there, writing methods, writing functions, changing functions, refactoring my code again and again, until one of the acceptance tests from acceptance test is passing. And then I go to the other one, and then I go to the other one. And if everything here is green, I'm done. And that's the moment when I call the product owner and tell him, hey, you know what? I have something to show to you. Is this right? Can you accept this? And he says, yes, looks good to me. You take it off of your sprint backlog and you're done. And you move on to the next story. If he says, no, I need some changes here and there, you address it immediately. And then you move on to the next story. That's this point down here. So this sounds horribly complex. And it seemed to be lots of work. And to some regard, yes, it is. But it's worthwhile because it gives you, at the beginning, it gives you a lower speed compared to your classical approach, but it gives you a sustainable pace. It's not that you start off with your engine humming at the highest possible performance and it overheats after a while and you have to stop. At this point, you can go on and go on and go on and go on. Right now, last Sunday, in the project I'm coaching right now, we went live with our first release. And in the past between going live and being productive, basically working, usually took about 3 weeks. So last Sunday, people went in there, they uploaded all, kind of put all the jar files and everything into the production server. 15 minutes later, the system was working. No issues. However, they have delivered a little bit less functionality than the business was expecting from the past performance. But now they see, hey, those guys, they promised us something, and they delivered, and it's working. It's less, but you know what? For the next 3 weeks, they can start working already without fixing bugs, because what they delivered is of good quality. This is where you want to get to. And this is why I like to show this chart here. This is from Barry Boehm, the cost of finding and fixing a bug. If you introduce a bug in the requirements and you find it on the customer side, it's really expensive. That's the worst case scenario. It goes up to, I think, factor 10,000 or something like that. Interesting is this area here. If we're between construction and kind of putting it to the clients, it's not that expensive. And this is actually, if you do proper testing and development in your Scrum sprint, this is the quadrant you will be in all the time. Because you set out to do something within a sprint and you deliver it done at the end. And if something happens within that sprint, you have a bug or something like that, you fix it immediately. And if something slips through and you find it afterwards, you fix it the next sprint. You're always kind of in control. So this really brings down the cost of maintaining the software and keeping it in a good state. So it's not only just looking at the return on investment, do I get the features, but it's also thinking about what is my total cost of ownership. If I get a product quickly, but it's of bad quality, I pay again and again and again and again. If I get something of high quality, I have really low maintenance cost in the long run. So let me summarize everything here again quickly. This is Scrum, product backlog, the development team plans, sprint backlog goes into, well actually this slide should be constructed step by step, but it's PDF, so sorry about that. And then we have the increment and the cycle here, and this maps perfectly to the approach I just showed you, because we have the product backlog, which is kind of the equivalent to our software specifications. And in the sprint planning, we derive all those acceptance tests and on the specifications we need for the developers to work on. And then once they have those, they make their own tasks. Okay, I need to create this table, I need to change this table, I need to have an OR mapping extension, and so on. And in this sprint, they development that. And the specifications we have here, they go into the quadrant 2. We define tests, which are then these tests here, going back to this graphic here, and then here for the unit tests. This is what we implement in here within the sprint, and this is where testing is really paramount. And Scrum tells you the team is cross-functional. What does cross-functional mean? You have all the abilities and all the skills you need within your team, because otherwise you cannot be done at the end of the sprint. If your Scrum team does not include testers, then tested software is never part of your definition of done. It means you will always have something untested at the end of the sprint. And this is how many companies implement it. And this is a problem, because you get a nice product rather quickly with very bad quality. So again, here this is the flow. You don't do testing and development separated in isolation, and you don't do it in parallel. You do it in a sequence. You first think about the tests, and then you do the implementation for those tests. Are there questions?